Hello guys, it's Sakari here. I hope you're having better day than I am. Like, I just got home from work and I wanted to go on Visual Studio and play with my lollies. But then I go to YouTube and checked what the channels that I have subscribed to posted, and Grimmy has had posted this OS basics, like how OS works. But the problem with this fucking video is that it made me angry because it really doesn't, like, it's bad, but it's like I wouldn't say that the video is wrong, but like it really misses like the important parts. So it's, I don't know, misleading, and it made me angry. So I suppose I have to make this response video. Grimmy left me no choice with this. It's kinda unfortunate that things had come to this. Like, what I'm worried that like when people watch this video, like now they have like some basic idea how OS works and like what's the thing with OSs in like at basic level, but it fucking doesn't tell you shit about that. That's the problem that I had in this video. I mean, it has some facts and it's not really wrong, but the problem is that it misses like the critical stuff, and that what made me angry. So I don't know, like, well, we are not going to watch the entire video. I'm going to put like link to this video in the description so you can put it, but like what Grimmy is saying, like, oh yeah, we like, he's just starting about like the boot process. So like the common boot process, like we get into the BIOS, go in the kernel, and the kernel starts some shit, but like yeah, whatever, shouldn't really matter, I suppose. I mean, those are like facts, but like I don't know, not really, like, they're not really like all that important stuff. And like he was speaking about like shell scripts and that sort of stuff in the end, like, and I'm not going to even comment on that. Like, he wasn't saying really anything wrong there, but like, I don't know what the fuck am I saying, I'm rambling about, but like let's get to the problem. Like, yeah, so basically he was saying how OSs work, and what his video is saying that, you know, we have the BIOS, it boots the kernel, and like outside the kernel you have like these shells running, which can be GUI or some sort of text-based thing, and I don't know. Yeah, and then we are talking about the shells and stuff, but like the most critical thing here is like the most important, like the most basic thing is missing, which is like, how do OSs basically work like in the most basic, like the most fundamental, like as simple as you can get it, like, and the most important like core part of the OS. Like, that's what he missed, and that's what excuse me, I was drinking some Pepis actually. Let me take a sip. nice peppies. So at like the most basic, the most fundamental, the most core part of OS is like it's like the OS API stuff, or the programming interface. So as he said, like you have the kernel here running, it has some drivers. We're not going to talk about drivers or whatever, but like I don't know why it even put it in here. Does it doesn't need to, but yeah, doesn't matter. The kernel. You know, we have the OS kernel here running, and we have like different oh fuck. Yeah, excuse me, wait a second. I'll try to draw and like I'll explain after I have done the drawing. Hardware and like there's like your programs. Yes. So what's the most important, the most basic part of OS is that it provides you this one single target where you can ship software to, that it can run on different hardware, the same OS. That's actually the most basic and the most core thing about OS. And what does it mean in terms of like actually working? It means that the OS, like kernel and drivers, they know how to talk to different types of hardware, and all these programs can then talk to the kernel, and this, like the interface from the programs to the kernel is like, there's like one interface that's like fixed, that's like for Linux is the Linux system calls, and like Windows is like the like Win API and the stuff in the bottom of it, and it's like a single interface where you can like ship and target all your software to. So all your same software can run on different graphics cards, different sound cards, like different hard drives. You use the same interface. You have the actually same program running, but it can use different hardware down here. Like you can swap the hardware, and like the kernel and the drivers figure out how to, like the requests coming from the program can be translated to instructions for this type of hardware. So like I can ask, like if I ask to read a file, there's like a Linux system call like read, or in Windows there's like a call to the read file. So that one request goes to the kernel, and the kernel then just figures out with its drivers and its stuff, all the kernel code figures out how to do it with this type of hardware. Let's say it's a SSD or it's a CD drive. Maybe it's like some sort of network mapped file, so it needs to communicate over network. So it's like different types of controls will be needed depending on the type of hardware. But like from the program perspective, there's like, it just requests like read. I mean, that's the Linux way of doing it. the Windows way is the read file ex. That's. But yeah, the point is like, what's the OS? Most basic thing from the OS. It provides a single interface that you can ship software to. So you basically ship your software to the interface of the OS, and the OS can then like translate your software requests to all different types of hardware the OS supports. So this is the most basic, the most simple, the most fundamental thing of OS. Like, this is literally the whole point of why OSs exist. So your program doesn't need to know how to talk to millions of different types of hardware. Like, that's what the OS does. It knows how to talk to all the different types of hardware. And it just provides you like a simple way how you can talk to all of the hardware through it. So yes, that's like, well, that's not like, well, I'm not going to add like other stuff to this video, because I just wanted to say like the most important, like the most basic, like the most fundamental thing Grimmy missed in his video that angered me. Like, I don't know, like, you can watch his video and like see all the other stuff he has to say, but like, this is all I wanted to add, and like, it would be nice if Grimmy had even mentioned about this. I don't know how long this video is by now. 12 minutes already? What the fuck? Anyway, like, I was thinking like maybe I could like show you concretely what does this actually mean. Like, how do you like request stuff from the OS? Okay, I mean, maybe I'll do it like short, like just a few minutes. Okay, here's like Linux. How do you talk and request stuff from the system? Like, the interface for Linux is, as I said, you make these syscalls that are like requests to the kernel to do something. Like I said, like there's the read. You can request to read a file. You specify like a file descriptor, or that's like a Linux thing that use that like, well, okay, I don't want to go like in the Linux specific stuff, but like it just describes a file. You basically, this just says what file are we talking about, and some buffer where you're going to put the data, and how many bytes do you want to talk. Read. I mean, it's pretty, the interface is just pretty nice. You put like, specify what's your request by number, putting it into the arrayx register, and RDI register has the file descriptor, RSA has the buffer pointer, RDX has the byte count, and then you just make the interrupt into the kernel mode, and it will process your request. That's the interface for Linux, and let me show you the interface for Windows. You know, I have Windows running on this machine, so we can do that. Hopefully I won't open something too spicy for YouTube and have to re-record this video or something bad. Alright, so Windows different than Linux, of course. So how does it work on this system? Well, we have this folder called System32, which has like a bunch of DLL files and default programs and shit. So when you run programs on Windows, you talk to the OS through the DLL files located in this directory. Just also just called like the system directory. And I have this nice program that can analyze some shit about DLLs. You can see like what's the interface this provides. You can do this sort of request. Let's see like are these sorted alphabetically? Yeah, let's see like you can find, can we find the read file that I was the read file that I was talking about earlier. It's supposed to be, it's probably kind of low, yeah. Read, yeah. Here's a read file. You can like link to the kernel32.dll and call read file from it, and it's going to instruct the operating system to read the file from you. This is there's actually like a bit of a lower level before it just goes into the kernel, which is on this anti-DLL. There's like anti-read file, which is just like read file actually just internally calls the anti-read file, and the anti-read file transitions into the kernel. So yeah, that's the Windows interface. And now, like, what's the point here? I mean, you can make a program that calls like a read file, and it can read files depending, like, it doesn't matter what your hardware is, or it doesn't matter even what version of Windows you're running. It will always like read the files, and you only had to like ship that like one software. You don't need to like think about differences between Windows versions. You don't need to think about differences between all the hardware you're running. You just tell Windows to read file and it will read it to you. Like it makes you able to just ship like one piece of software that's just targeting Windows, and it will work on all systems running Windows. And for Linux it's the same thing. You can just target your software to Linux, and when you put it like read syscall in there, the OS will like figure it out how to do it on like all the different systems. Yeah, that's the video. Also, I don't know. I don't know, maybe I should try to say something polite for Krimi at the end, but I'm not angry at you, just that this critical information was missing, and I think it's quite important on this subject, and so I don't know, let's just try get along, and yeah, so that's the end of the video. Bye.